So now we're going to even dig further into the discussion of ordering of results by talking first about how you can order results or how results are ordered for collections and how the choice of collection affects results orders. Now keep in mind, what is a collection? A collection is often used as a source for a Java stream and a Java parallel stream. So again, think array list, linked list, tree set, hash map, and so on and so forth. And we'll take a look at some really cool examples. These examples are all available in my EX21 folder in my GitHub repository. Definitely worth taking a look at. So keep in mind, encounter order is maintained in several ways. One is by using so-called ordered spliterators. Another is by using so-called ordered collections. And another is by using so-called static stream factory methods. And so we're going to take a look at some interesting examples here that will illustrate how this works. Here's the example we're going to look at. And again, this would be something you could play with if you look at my EX21 folder, and you could run it. So as you can see here, we're going to create ourselves a list of integers. And we're going to take this list, which is 2, 3, 1, 4, 2, and we're going to turn that into take this array and use the arrays.asList factory method to turn that into a list of integers that can be modified. So the encounter order here is 2, 3, 1, 4, 2. And the reason why that is the encounter order is because the list is an ordered collection. So it sets that little flag. It says, I'm an ordered collection, and it also can be used to store duplicates or non-unique elements. Again, remember that ordered and sorted are not the same thing. So when we come down here and we say list.parallelStream, that's going to allow the computations to be run in parallel. What computations are we going to be running? We're going to go ahead and only consider even numbers. So we're going to filter out anything that's not even. We'll filter out the odd numbers. We're then going to multiply the even numbers by 2. We're going to double them. And then we're going to collect the results into an array of integers. So this shows off a whole bunch of cool things that we really haven't looked at in great detail yet. But you can notice how we're going to use the toArray collector. And this will go ahead and create an array using this particular constructor reference. We're going to make an integer array that's going to store the results of doubling the even numbers. So that's the result, and that's going to get stored back in this thing called doubled list. And I actually probably should call it doubled array, because it's an array. But we've taken the original list and we've doubled what was in it. So some things will run in parallel, namely the filter and map steps. Those can all run in parallel, but the results have to show up in the same order that they were encountered, because list maintains the ordering, and as does filter and map. So the final results here must be 4, 8, 4, because obviously we got rid of the 3 and the 1, and then we doubled the first value 2, we doubled the value 4, and we doubled the value 2, so we end up with 4, 8, 4. And that's because a list is an ordered collection, and filter and map don't change anything with respect to ordering. They preserve the ordering characteristic or property in the stream. Let's take a look at a different example. This is going to be using what's called an unordered collection. And unordered collections are under no obligation whatsoever to respect encounter order. So here's the example we're going to use. We're going to use a hash set. So hash set has a couple of interesting properties. First, it's unordered, obviously, because it just hashes it, so we don't really know or care where it ends up in the hash table. And it's unique. So it only has one copy of each value, doesn't have duplicates, and it's also unordered. So once again, you can see that we go ahead and create ourselves a list, and then we take that list and we use that to initialize the hash set, and then we set that as the set of integers. Once again, then we say set.parallelStream, so now this stuff is going to run in parallel. And as with before, the processing will be the same, but the code is likely to run a little bit faster because there's no need for the terminal operation, which in this case is toArray, the terminal operation that creates the array. There's no need for this thing to maintain encounter order of the results. So the encounter order could come back as 8-4 or 4-8, doesn't matter. Notice, by the way, it doesn't come back 4-8-4 because a set cannot have duplicates. So it's going to strip out anything that was duplicate. So it doesn't matter which one comes back. Now, you might be asking yourself, if I've got 5 elements or 4 elements in my set, why do I even care, right? I'm doing parallel processing. Isn't that a little bit extreme? And the answer, of course, is yes. But I was doing this so it would fit on a slide. If you actually go and run the example that's in my EX21 folder, you'll see that I have like a gargantuan set of elements. And then parallel processing really does make a difference. And so you can see that the parallel stream version that uses the unordered collections will in fact run faster than the one that uses the ordered collections, because there's no need to order things in encounter order after all the parallel processing is done. So that was a quick overview, giving you some sense of how Java parallel streams work with respect to the order of results for collections that themselves are ordered or unordered.